Hello again to the Crazy Electronics Lab on YouTube, and recently I've made a video on the RISC-V microcontrollers and on GigaDevice, and I got a lot of questions from people. Hey Tam, this is very nice, but how do I bring the product into practice? And in this video I will be using this GigaDevice starter board, which you can get from various distributors in Europe and in America and in China. And I will be using a completely free toolchain with an IDE to do some basic like blink LED style developments. This of course is only one of the ways. You can also use YAR, which is paid for, or you can also use MBeetle. But this what I'm going to be showing you today. You have a nice IDE and it basically almost feels like the stuff from the big guys. So let's get coding. Our first step involves visiting this URL, and you see here we've got the Nulcei Studio IDE, and so we click this link to start the download process, and we get about 700 megabytes worth of files, and as you see the transfer speed is not exactly very fast. So grab a coffee. When the download has completed, you see we get here a zip archive, which we extract directly into the C drive. As this process usually takes a bit of time, I've done it in advance for you. And then we go in here and we click this file in order to start the IDE. And then it asks here for the creation of a workspace, and I'll just say 2021-02. One interesting thing, if you work productively with GigaDevice's Nuclei Studio, you can also create individual version folders like this to keep the versions apart. But now it doesn't matter. Let's click Launch and we see Nulcei Studio Startup. Essentially this is an Eclipse CDT based product, so it should not have any significant surprises for those of you who've already been developing with C before. Another video, another begging scene. I know. Like, subscribe, comment. Thank you. When the IDE starts up, as always, first we need to close the welcome screen. Then we go here, File, New, C++ project. We select a C managed build because development for the GigaDevice is mainly a C affair. Then here we get the various templates. We of course want a GD32. We call it GD test 1 while avoiding spelling mistakes. Here we can select the board. I'm going to select the eval, which is the large evaluation board. And then we go here. This here has changed. Now you see we no longer get a blink benchmark, so instead we just select bare metal hello world, click, finish, and now Eclipse CDT essentially will do what it wants. And then we see we get here an inclusion of the SDK files. And then here we have a main method, which is important. This is for accessing the product. And now in theory, we can run this. But in practice, of course, we want to blink an LED, which in the past we could have done with an integrated sample. And so instead, we must now go here, GD32MCU.com. And here, this is important. You see, I'm clicking English version. That's the first thing. And then we go here to the download. And now we get into this new download portal, which actually I find it pretty nice because you've got over there the list. You just go there, you mash the button, and then you only get the resources which are of interest for our system here at hand. And now here we can look up and down. We're going in here. And here we have the firmware library and so on. And yes, what we need is the firmware library. And we see here there recently has been 2 releases. we want the very latest, 1.1.1. So we click the file symbol, and now we get a RAR archive. Yeah, I know this is a bit annoying, but WinRAR is invented, and so we wait for this file to download. Incidentally, you see here, if we click this, we can also get access to all kinds of application notes. And it's important that by default, it always only shows 2 of each resource. So this button is your friend, and yeah, there's some additional filtering here on top. And here we already have our GigaDevice Firmware Library. We click it here, and we see examples, and we get examples for the various components. And as you see here, I normally extract it into a subfolder of the Nulcei Studio. And now here we can go into examples, for example, examples GPIO. And here we have running LED. We click main.c, and it will open in a C editor of your choice. With me, it's always Visual Studio because this is my Windows workstation. It takes a bit of time to start up. And then we already see here the code. And essentially playing with this thing, it's always the same. So you need to take the code from here and you need to put it into your solution, just like we've been doing it on Microchip and on all the other systems. So let's start off. Print Misa was nice knowing you, we don't need you anymore. All of this stuff was also nice knowing we don't need you anymore. And instead we go in here, we grab all of this stuff, and we put it in here. Then we go over there again, and we see here the includes. So we take all of the includes, we put the includes in here, and basically we just have to merge it. Oh, we are missing systic.h, and that's something which we can look at next. Systic.h, where is it? Here it is. Here we have systic.c. You see this is responsible for the delay method. So we can save us the effort and we just take it and we put it here. And now we have a basic version of the thing. And at this point, the old law of Diomedes Spinellis of course confirms itself again, that you should treat any program as working. So we compile it, and here we get the collision, because thank you very much Nulcei Studio, part of the SDK already is included. So here we click again, compile, and now it works. And now I want to show you something interesting. You see over here the folder Nuclei SDK, and here we see both a subfolder board, which contains various routines such as LED on and LED off for our evaluation board. And also here in common, you see the includes and also the source code for the various peripheral drivers. So we usually don't need to take them out of the archive which we downloaded. So instead here we can click again the build symbol. So, and now it's time to get an overview of the board which I will be using. The most important part is this here at the bottom. This is you see here it says, if you turn it like this, it says GD link. This is the connector for the integrated programming device. And we will be using a mini USB cable which plugs in here and which we then connect to the workstation, as so. And then of course we need to also switch it on. And now we see the display wakes up, and if this is a completely untouched board, the display will display some demonstration applications usually. If you already installed something else, it starts up like this instead. And yes, you see here, these are the actual pins from the core. Here in the back we have an output for the DAC. Then we have here a little 5-way navigator and the reset button. And now for the final act, we go here, we click this symbol. Now we see an OpenOCD port opens. This takes a bit of time. And then eventually the board will restart. And finally, we will see the marching LEDs shortly. you see it's still padding the image, transferring the image. And now when we are here at prev, we see that the LEDs will start to march. And yes, you see here the 4 LEDs at the bottom. They are marching along, nice and slow. Maybe we can zoom in a little bit. Yes, we can. And here you see the LEDs once again in a close-up as they are marching along happily. And incidentally, when you click run, the program stays on the board. So you see I switched off, I switch on again, and the running continues. And while this was fun, now I'm going to click here to set a breakpoint, clicking configuration debug, and clicking here on the debug symbol. And now we see it's still firing up. It asks for a permission to switch the perspective. We grant the permission. And now we have to wait a little bit, as always, as the padding takes some time. And now we have to wait a little bit, as always. And now we see here we've got the introductory breakpoint. We jump over this one. And now here we are. We've hit our breakpoint. And basically you can now debug this as if it would be any normal Eclipse CDT project. And now, as the next step, we send the program here for a test. And even if we click reset and wake up, we see nothing happens. And the reason for that is pretty simple, because here the pinout is a bit different. And now, as the last task, I want to show you how we can harness the API to fix this problem. And yes, incidentally, here on the small one, you also have this embedded GD-Link programmer type thingy. So, now the first thing is we need to find out which pin the LED is attached to. Traditionally, there used to be this file which I've highlighted here, but in new versions of Nuclei Studio, they don't support it anymore. So, well, I just did it by hand because we know it's A7. And so the code essentially looks like this. First, we initialize the GPIO pin after having provided it with clock. Then we reset it. And then you see here, we simply do a writing over and over and over again. And if we would run this program, we would see that the LED starts blinking. And one thing you should note here, you see here there's a flag which sets the speed of the GPIO pin. And here there is a flag which sets the push-pull mode. And essentially what GigaDevice did was that they designed the peripherals so that the design ideas which you face during the development of your hardware are very, very similar to those which you face on an STM32. So this makes getting started easier because you can recycle a lot of the experience which you have with the STM32. And then, very finally, here you see the blinking of the LED, so it's proven that our little operation has worked out just perfectly. Okay, so after these experiments, we got this LED blinking. Now, of course, an important question remains, namely, is it worth it? Well, if you compare it to the more established products, I've used Cube a lot. Of course, the graphical code generator does make life a little bit easier. On the other hand, however, the GigaDevice API is so simple that it's not really a problem to just take the relevant bits of code, fleece them, and dump them into your example. And as I've already said in my RISC-V FAQ video, going RISC-V has many, many benefits. And as you've seen here, the stuff doesn't cost much money and there's a free IDE. So, if you are concerned about ARM, NVIDIA, about sanctions, or you just prefer open source technology, this is the way to do it. all the best of coding. Thank you very much for following, and stay tuned because more material comes real soon.